Yes, welcome to this session. And we have caught up a little bit of time, but we still only have time until 3 o'clock. We should be finished. So we have to speed up our session a little bit, but hopefully the quality will be the same. In this session, another two big strategic topics in the industry will be debated. Industry 4.0 and the green revolution in the railway sector. Industry 4.0, or the digital railway, as it is known, is a relatively new initiative that every industry stakeholder has been taking on board over the past few years. To implement new technologies in the rail operations by consolidating the latest digital technologies and business processes is a massive transformation process and provides a great challenge as well as a great opportunity for an industry like rail. It is also a key ingredient for the implementation of new mobility concepts. It is a question how quickly the railways, an industry which as a whole is not exactly known for fast evolutions, can transform by embracing these new technologies, hereby also learning from other transport modes. The green revolution is another key development which has been accelerating with newest technological advances made in other industry and transport sectors. For the railway, who have been basking themselves for decades of being the most environmentally friendly transport mode, has really woken up now from the swift progress we see in other transport modes and have taken the initiative as well. Both themes are quickly becoming the essential ingredients of the future railway. Without it, the rail transport will become a laggard. Supported by the transport megatrends, such as integrating different transport modes, introducing automated, safer traveling, and at the same time significantly reducing pollution and noise emissions, rail transport will seek to reinvent itself. As a first speaker, we have Mr. Paolo Guglielminetti, partner at PwC. And he will give us a great introduction how society megatrends are affecting changes in transport and what are the key drivers of those changes. He will also talk about the key factors to ensure innovation and sustainable solutions in the mobility sector. Paolo Guglielminetti has been a partner at PwC since 2011. Earlier, he was working in the Swiss Federal Institute of Technology.
Thank you, Chairman. Thank you, everybody. Good afternoon. Thank you for the organizer for inviting me. This is a fascinating topic because mobility is strongly changing nowadays, and the role of the railways is at stake. It's one of the oldest modes of transport, need to be in the first place in this change, but at the same time it should overcome some of rigidity, some of characteristics that are making this change more difficult. If we can go to the next slide, what are the mega trends? We have the, thank you. The green, yeah, the easiest. Always technology, not that easy to be applied. So there are some megatrends mentioned in the topic of this session. In our vision, those megatrends are touching all the society, and briefly explaining them. Of course, we have a strong technological innovation period. At the same time, we have also changes in the society that are quite relevant. We have shift in terms of demography, not just in terms of different rate of growth in different parts of the world, but also the aging of the population, especially in the Western world. So modification in the structure of the population, at the same time of the economy, with the shift in the economic power. What we are discussing those days about the trade between Far East and Europe is also part of the shift we are seeing, we are observing in the economic power. At the same time, the structure of the territory is changing. We have more and more people living in bigger cities. Urbanization is accelerating, and this means also that we are competing to the use of scarce resources, and we need to face the climate change and address the problem related to that, because transport sector, by the way, is a strong contributor to that. So these are the mega trends. How this is affecting the transport sector? There are, of course, a number of changes, and due to the time available, I will not go through one by one. But in general, what I would like to say is that not just customer behavior is modified. This is certainly one element, and I will come back on that. But also, production and service model are modified by those megatrends. We have, for instance, the capability to propose an integration of service across modes thanks to digitalization that was not possible in the past. We have also the possibility to propose new modes of transport. We have important impacts in the sales channels with an increased role of online platform for information, but also for ticketing and booking. And we have changes in the competition because we are the emergence in the mobility sector of new players that are coming from other sectors, from automotive, from energy, and also from IT, needless to say, third-party players that are operating just platform to book your travel solution. This poses important challenge to governance and regulation. We need new regulation adapted to this world that is evolving. This general picture is not just theory. We clearly see changes and tendency when we look at the figures related to, for instance, passenger mobility. The tendency today for the population overall is different in different parts of the world, but we see a tendency of stabilizing the mobility intensity, especially in the more mature country. In European Union, for instance, we are at about 13,500 kilometers per year traveled by each person, all modes of transport included. And this in the last year has not increasing so rapidly as in the past. But at the same time, there is a higher variability of travel patterns. We have less systematic trips. We are not traveling from same origin to same destination every day of the week. And we tend to use more and more intermodal solution. Also pushed by the need of having greener transport solutions, so the need to use, at least for a part of our transport, public transport or car sharing, a solution like that. In the more organized urban agglomeration, up to 20% of the trips are really intermodal. And we are the emergency of car sharing, I already mentioned. All these elements are driving to the development of smart mobility solution, because if you need to change every day your travel pattern, if you need to use different transport solution, you cannot rely on the information you already know about transport modes and transport itineraries. But this smart mobility solution needs appropriate regulatory condition and business cases. Otherwise, they will not survive. And I will come back on this on my conclusion. Also, freight is facing changes. Has been discussed quite a lot during these days, so I'll not pass a lot of time. We have increased complexity in the logistic chain. As for the passenger, we have more and more complexity, especially for the long-distance transport. The more international trade over long distance we have, the more complex the logistic chain. We use larger transport vehicles to have economy of scale, but this means that we need larger, faster, and more efficient transshipment hubs, also using automation. And we have more and more e-commerce flows, and in general needs of consolidation. That means the last mile operation are crucial, and the efficiency of them is a key factor. So digitalization and complexity are common features for passenger and freight mobility. These trends are, at the same time, needs to address the issue of sustainability. Transport is still a very important contributor to energy consumption, even more than in the past, and is also impacting significantly on urban congestion. So any transport solution in the future should address this topic. The smart mobility solution as well. When we move more vehicles autonomously, for instance, across the city, we have to consider that this does not automatically reduce congestion. In larger cities, we have seen in the last 7 years plus 30% of travel time due to increased congestion. So this is the general picture. What should be the role of the railway operator? And I think this is my conclusion, but also the most important topic for our discussion. Facing all these challenges that I summarized in 4 topics. First, we have to address variability of travel patterns and logistic needs. So we have to be able to design the service for different personas, different market segments, much more than in the past, increasing the level of flexibility in designing the service and in the operation. Intermodality is already on the table of railway managers since a lot of time. We have to develop it both physically, and we know how to do it, but also digitally, interconnecting the modes of transport and ensuring that this touch also the last mile connectivity and efficiency. Digitalization. Co-design and partnership. Digital is an ecosystem. It's not something that one operator can develop alone. It's necessary for smart mobility solution and smart logistics. But also we have to use it to understand better the transport demand, using the data available from the solution and improving the customer experience. And finally, and probably the most important topic, we have to properly define the business case for smart mobility. We understand and monetize the benefits arising from smart mobility solution, including the environmental one. We should be sure that we are not losing the traditional capability of railways, that is achieving economy of scale. We have to use digital solution to feed our system in a way that economy of scale has preserved. And we have not just to observe and thinking that is a topic that is to be developed by third parties, startups. Railways should be at the center of the changes, but at the same time, they cannot be monopolists. Again, they should develop it in a framework, in an ecosystem together with other players. I'm finished. Thank you.
Thank you very much, Mr. Guglielminetti. No, that's fine. I have the microphone. We now have... thank you. We now have Mr. Sergey Kobzev giving his presentation. He has been a chief engineer at Russian Railways since last year and also serves as a deputy CEO and member of the management board of JCS. And he will tell us about the impressive energy efficiencies his company achieves and the Moscow digital circle as well. Thank you.
I would like to say first I'll say a few words of thanks for the very good ideas that have been expressed during this conference, especially with respect to application of green technologies in transport. Now, what we are basing our green technologies on? These are a few statistics, and they date from January 2019. We can see that Russian enterprise is actually quite leading in this respect. We are use electric traction, and this has helped us, of course, to scale down the environmental impact. And moreover, we work, of course, with gas as well, and we are trying to reduce this sector in passenger traffic. Well, we've achieved a great deal in the field of electrification.
$83 тысячи километров – это протяженность российских железных дорог. Из них 20. Мы еще будем вводить этот вид энергии. Это основные участки, где наибольшая складывается грузонапряженность, те, которые сегодня.
So this kind of energy, there are certain bottlenecks, and then there are, in the perspective, of course, we do have quite many more things on our schedule. We are also actively working on defining the optimum lines, the optimum routes for trains. And there is a system which wants to harmonize transport and, as such, also optimize and reduce energy consumption. The moderator also said that there is a central ring around Moscow, and I would just like to give a couple of points when we now make a comparison with other modes of transport, where certainly rail is coming in first, especially when we take the central Moscow ring. The project of passenger flows at intervals of 4 minutes was a challenge that we have solved by simply going for digitization. At present, we can also cut intervals even more because our city is growing and the population is growing as well. So transport is therefore also increasing. A couple of figures. 3 years ago, we thought that the daily number of passengers in our project totals between 150 and 200,000, whereas at present we are having 500,000. All of this, of course, is very punctual. 98% of punctuality also affect the Moscow Central Ring, where we have a 99.6 punctuality rate. Yesterday, a colleague also mentioned the Internet of Things. So we focus on having our trains get the information directly from the environment. These digital trains measure their environment actively and reflect it in the respective electronic systems. One further fact on the Moscow Central Ring. Here, of course, we are having a certain profile in the increase of central routes, and we therefore also consider the energy where the train itself can also create energy and can feed itself through the declining territory. Here, of course, we have not invented the perpetuum mobile, but by doing so, we minimize energy consumption. In the Russian Federation, this is also something that we saw with the transparencies here, with the Eurasian projects and the transport corridors in this territory, where we're having some spontaneous regions. And here we must say that the accumulated energy of the train is increasing used here. We believe that this is a real trend, and we still keep working in this direction. We want to promote green technologies and therefore also the competitiveness of trains globally. Thank you very much.
Thank you, Mr. Kobzev. We have now Mr. Stefan Geisperger, who is Senior Vice President and for Sales and Maintenance Services. He is currently responsible for DB's global sales activities in the area of rail maintenance. He has a degree in mechanical engineering, and also before joining DB in 2013 has significant experience outside of the industry and with an automotive supplier. He will tell us about DB's IT solutions, Colibri, 3D printing, condition-based maintenance, and the digitalization of operational processes. Thank you.
Yeah, thank you very much. We prepared some issues to discuss here and to present to you. First of all, DB is going to be a digital company. Maybe in the future DB will stand for Digital Brother. We have a board member, a professor, that is responsible for technology and digitalization. And DB started a quite interesting initiative. DB will give to each of his members of the company a smartphone. Even those who are not managing positions that are working in the shops, every conductor, every train driver will get a smartphone, because DB wants to connect its members and to start the digitalization process internally. We will talk about, in my presentation, I will go a little bit more deeply into what is really going on. And we are, as DB Maintenance, we are probably one of the biggest maintenance companies in Europe, serving both the internal companies at DB, but also serving the external companies both in Germany and Europe. This goes right in the direction of the Moscow digital environment. This is basically our vision, how we see the future, and some of those elements have already become real, and we are working on that. If you let me allow that, I think that at the moment we are putting a puzzle together where some of the whole masterpieces is already seen clearly in a more distinct way, and some areas we are still working on and trying to find the right puzzle pieces. But we are really active in putting a lot of puzzle pieces together. I'm going to highlight especially also on the maintenance side of this picture, not in terms of digital rail. There's another story that you could cover, maybe 2 presentations, and maybe to fulfill a whole seminar. I highlighted, due to the short time we have here, two digital solutions that we are already offering to our customers. One is a self-developed digital solution to equip existing trains, used trains, with a digital system. And I'm going to highlight on that. And then we are very proud that we make the 3D printing process available and ready for the rail industry. And if you allow me, today, maintenance, nobody wants maintenance. Why? Maintenance always costs money. So the transporting guys always hate us. And we cut and take away availability. So the best maintenance is the maintenance that is not going to happen. And we are working on that. And we are trying to cut lead times. And 3D printing is a very substantial contribution. I will skip condition-based maintenance, where we are strongly working on, and also the internal digitalization, as we saw. Giving smartphones to members is only one point, but from the order intake until the operational process in the workshops, a lot of initiatives are going on. Colibri is an acronym for our self-developed system. What we basically do, we transfer data from the train to land That's basically the whole story. But we do this on a modular basis. We do this on an open basis. So for used vehicles, we offer a product where existing trains can be refurbished and can be re-equipped with digitalization. And a lot of our customers are already using this. At the moment, we have 1,000 vehicles running with this system in place. Basically used for Wi-Fi in the trains, for customer experience, but also more and more in terms of using diagnosis data for the train condition, passenger information systems, customer count systems, and so forth. Coming to the next digital point, and I even brought an example for you that you see that this is not a story that I'm talking about or a project, but we're actually working on this, and we have the first 5,000 parts in practice. We started an initiative together with the SBB, together with ÖBB, together with the industry, and we are not printing parts, but we are developing the technology that it is usable and available for the rail industry. And in order to do so, we looked at several use cases, and what we basically try to do is we substitute parts that are not longer available, obsolete parts, or we try to cut cost with a better technology than the existing ones. So a variety of solutions. What we even did, we started an initiative for our employees to look and make suggestions what parts and ideas that they would have that we can take on and try to develop 3D solutions for them. I brought with me some examples. This is an example from DB Netz, from our infrastructure company. Small examples, but look at this plastic cover. This is not longer available or very expensive or has long lead times, and we developed a solution out of 3D printing. Now, plastic is easy. You can buy a plastic 3D printer for your private use, but we developed this system further. This is a sand guide, for instance, for a locomotive, where the part was not longer available or the lead times would have been too high, so we printed it in 3D. And the vision is that if you put all the pieces of the puzzle together, that in the future we will get information of the part that has to be exchanged as long as the train is on the rail. We start the printing process as long as the train is on the rail. We have it available already when the train comes into the workshop, and we exchange it in a very, very short lead time. So also the transportation guys will be very happy then, because maintenance will be cut down by, factors of 10 or 20. This is another example, so braille indication for our station and service company, and so forth and so forth. So we could give you a lot of examples. A quick overview about DB's activities in terms of digitalization. We are preparing ourselves. If you have further questions, then don't hesitate to contact me. I brought some samples with me over there and some information material. And yeah, I'm open for discussion later on. Thank you very much for your patience.
Thank you. Thank you very much, Geisperger. This was very interesting. We now have David John, who is CTO at TMH International. He has a long history also with Siemens in Moscow, for example, as a general director of rolling stock in Russia, and he has also been general manager of high-speed and intercity trains in Russia. So John will give us an insight into the areas of digitalization for running vehicle fleets, especially older ones, which might not have been so well maintained in the past. Thank you.
All right. I just want to use, let's say, the speech of Mr. Geisperger actually to further elaborate on the possibilities how to use digitalization in maintenance. Of course, for the new fleets, for all of you, it's more or less known that you can install a nicely train control system which collects all the data, sends the data out for elaboration, for data analysis, for these big data rooms, etc. But and of course there's the art more, what kind of data do you select and which bring you really results you want to have. But for old fleets, what do you do on these? And let's exchange ideas what we can do there. And for the old fleets running for many years, you have maybe two categories. One is you have a very well-established maintenance process running with the old-fashioned way. So that means everything is on paper, you have the processes in place, it works, it's fine. But you still want to improve these processes. So how to do it and what can you do on these? And the other category is fleets which have been supplied quite cheap, which have been used for a certain period of time, but maybe without maintenance, maybe without processes, in a very bad shape. And in the world, you can find these kind of fleets where it is really hard to continue the operation. And even there, you can think about what to do with the help of digitalization to improve the maintenance. Of course, it is for the first category, there are certain steps you can establish. You can, of course, start to replace certain aspects of the processes. You can start to collect these data which are on paper in the databases and then to do the analysis. It's possible and easy. Of course, you can think about to add to the vehicles more sensors and to collect data, but that is quite costly. And therefore, there was also an idea born where you use, let's say, mathematical and physical models to remodel the system by using a computer, and then use data which you have. Some of them are always available, and to remodel, and by having this model running, of course, it's not online, it's an offline or not real data. Then you can predict the other data which you are miss. And by having these possibilities, you find out what is the condition of the vehicle. There are out in the world engineers which have done it, and that's a quite sophisticated possibility to improve the situation on these old running vehicles. On the other hand, you need, of course, you can apply the method to have, let's say, stationary diagnostic systems. So it means once these vehicles come into the depot, you can try to have a diagnostic system like measure the vibration, measure the noise, etc., and find out what is the condition inside of the model. Of course, you need to know the system quite well, but by knowing and elaborating and modeling the system, you can have these, let's say, predictions of the condition of the vehicle which you have in front of you. And of course, last but not least, also you can try to collect all other data which you have in the operation to get the improvement on the maintenance and to get the improvement on the condition of these fleets. And I think why we are talking about these possibilities, as of course many of us think about new fleets because that's what we are talking about every day. And if you look at the overall fleet in the world, then old vehicles are still in majority, and we need to think about them. And sustainability means also to keep them running and to keep them alive in an efficient way. And therefore, I think it's a good link to implement these new technologies to improve our life. Thank you.
Next speaker is Michele Molinari. He's CEO and chairman of a company called the same way, obviously. He has a background, he has been on the board of directors of Sergey before that. And he will introduce us to technologies for the most suitable, the most sustainable mode of transport. Thank you.
Thank you very much. Just as a starting point, we are at Molinari in the first place engineers and consultants with a high passion for railway solutions. Our focus is railway transportation and all kind of vehicles which go on rails. And we focus on rolling stock, and we are active as system integrators. As such, the clients asked us always about to have a look at the life cycle and to think how their vehicles will behave over time. And I agree with David, the majority of the vehicles are not brand new. And the investment done into this vehicle has to be taken into account. We cannot just throw away 10-year-old vehicles because there is a better one. This is not sustainable, and especially not from an investment point of view. In our company, we have a strong R&D and technology department, which we pair with our manufacturing capabilities, and we combine this for the creation of projects, which are the tasks our clients give us. And we are active as integrators and manufacturers in a variety of projects. I would like to focus on three major things where we look at when we think about what the client asked us. First of all, of course, the passengers. Now, when we have passenger-centric vehicles, etc., or then the freight, by combining the technological, let's say, advancements, etc., and to combine this with new manufacturing technologies, new material, etc. I don't want to go now into the details of all, but I think the whole system is a continuous evolution and improvement. Sometimes today or yesterday it was talked about disruptive technologies. I think that's rather difficult to see in such a rather conservative industry like railways, where R&D budgets or, let's say, innovations need to be proven very much before they can go into production, etc. So the gradual improvements, let's say, which improve system safety, the passenger experience overall, or the further improvement of lightweight technologies on how we design and build, let's say, for example, aluminum car bodies, or then how we cool and heat the vehicles also in order to lower energy consumption. This goes together with the application of new manufacturing technologies, new ways of thinking also of how to build car bodies, which then at the end will find their way into an improved operations, lower operations cost, lower energy consumption, etc. And this overall, this sum of small gradual steps lead to an improved systems over time. I would like to show you some examples of what we are doing in this field. For example, and always with the idea, and we have been working at this, let's say, about the last 10 years at least, by focusing on projects where we can reduce the carbon footprint, where we can reduce the time of the people in the system. The first one I would like to present to you is the hydrogen narrow gauge train, which together with Mr. Schreiner, who sits here to my right, we are supporting Zillertaler Bahn in the definition and the implementation of the first hydrogen narrow gauge regional railway train, which we hope that we can give the start pretty soon. I like this project very much. much because the hydrogen is produced locally, but I don't want to say too much what you are going to reveal, Mr. Schreiner. But I think it's a very nice example to combine new technologies with at a place where hydrogen can be produced easily and makes a lot of sense. Then we are very proud that we collaborate also with Plasser and Teurer in further developing their maintenance and tamping machines so that they can be driven with electric traction, and so they have a dual system, and the response from the clients has been very, very good, and I think this makes it more efficient, reduces noise, they can work better in the nights, etc., and it's a very nice example. To the right, this at the bottom right, this is a so-called auxiliary power unit, where the question was, how is it possible to have a big 4,400 or 6,600 diesel electric locomotive to shut down, to reduce the number of working hours of the engine without using really the locomotive. This is a project which we are delivering to General Electric for India. With this small auxiliary power units, it is possible to shut down the big engine and really use it only when traction power is really needed. And in the meantime, the locomotive is active, up and running, it is braked. And the most important thing is that the loco driver has air conditioning. So if it's hot and humid in India, the loco driver has to be taken care of. So that's a very important point also. Yes, I will finish. One more example, New York City Transit, reduced energy consumption by heated floors. And a project which I like very much also is Freight Wagon, which produces electric energy for cooling containers, which are then self-sustained. These all together, I think, is a little glimpse of what are the gradual technologies which are there, which are being implemented, and which are looking out for more clients to adopt them. Thank you very much.
Thank you. Yeah, we now have Helmut Schreiner, who is CTO of Zillertaler, a public transportation company. He has already taken a leap in the future by embracing a new technology with the procurement of new trains for the Austrian Zillertaler Valley. And unfortunately, we don't have so much time to go into very much details, but I would be highly interested to hear about as well the technical as also the economical solution of this new procurement.
Yeah, thank you very much to have the opportunity to make a small presentation of our Zillertaler railway project. So we are a small railway company, so we make a short presentation. I want to show you just the network. The network of this Zillertaler railway is about 32 kilometers. We had 18 stops on this railway network. And the Zillertaler is well known for skiing, for sport, for holidays, but also well known in Austria for reasonable technical problems, for reasonable traffic problems. So from this point of view, the government of Tyrol decided on the 1st December 2015 to electrify the whole railway line in order to accelerate the trains, to enlarge the number of trains. Unfortunately, the local mayors in the valley did not want to have additional catenary poles, an additional catenary line. This was one reason why we looked for other solutions, and in collaboration with Molinari Rail, we found the solution in the new hydrogen trains. To speed up, to accelerate the trains, it was necessary to have trains with a high acceleration, which means we need additional power in the trains. With the normal diesel fuel trains, this was not possible, so we made an public procurement with new trains of about 1,400 kilowatt of power in order to make sure that the new time schedule will be kept. This is the new train. We have a gauge of 760 millimeters. This was very familiar in Austria. We have a maximum power of the train of 1,400 kilowatt, maximum force on the level on 180 kilonewtons. This was necessary in order to fulfill the obligations of the new time schedule. Operating speed in the valley is 80 kilometers per hour, maximum speed is 100 kilometers per hour. So the train was designed, it's finished, and the biggest problem was to estimate, to calculate what is the power, what is the kilogram of hydrogen needed that the train can run. This was the big story which we have to calculate, and we had also to increase the number of people be transported from, in these days, 225 people to 452 people in order to have, in case when we make later on the connections to the existing cable cars, that we can also fulfill these obligations. Yeah, the new train will be about 75-meter long train, in total 16 axes. 8 of these axes will be with motors, which we have the high acceleration of this train. Then we make the hydrogen, the dynamics. We take in consideration how much is the consumption of the train. This was big calculations necessary to, first of all, to make the business case that we know how many kilogram of hydrogen we need per year. We know now that 292 tons of hydrogen per year is needed for the train, and we have also to calculate the tanks, to design the tanks for the train. In total, one train has about 320 kilograms of hydrogen with him in order to run these 500 kilometers per day. Of course, also we have to take in consideration temperature. Everything was taken in consideration, also the end of life of the fuel cells. The final consumption is 0.38 kilograms per kilometer for the new train, and this consumption is then the base for the design of the train and for the calculations of the business case that we have to do in order to get the public procurement transport contract. The train itself will save 800,000 liters of diesel fuel, which we need per year. It will reduce the travel time from this time 54 minutes to 45 minutes, and the average consumption of the new train will be 0.38 kilogram of hydrogen per kilometer. This was the basis, and with this we go in the business case and we go in the new time schedule. Also, infrastructure is necessary, because one problem is you need much more energy, electrical energy, than in normal catenary, catenary trains. Fortunately, we get a good offer, and we collaborate with the local Austrian power producent Verbund, which gives a good offer, because the big advantage is that we can produce the electricity during night and also the hydrogen during the night, where you get very good prices of the electric power. And for this, the business case worked, and we were competitive with the normal catenary system. This is an hydrogen. This will be the new hydrogen fuel station in Meierhofen, which will be placed there. Verbund is producing the hydrogen itself, then it is storaged and fueled in the trains during the night time. The train can run the whole day without being stopped, have enough hydrogen with him to run the whole day, this 550 kilometers per day approximately. This we will use a proton exchange membrane. This will be the 2 times 4 megawatt water electrolyzer. This will be used in Meierhofen to produce the hydrogen. Of course, you have different scenarios. The maximum hydrogen we need per day, this is a hot day, the train is completely full, it's stopped in every station. It's stopped in every station, which means 1,280 kilograms of hydrogen is needed. And for this, the design of the tanks were made, which means 320 kilogram tanks in the trains will be placed. The storage capacity will about 4,000 kilograms of hydrogen. This will be stored in Meierhofen in special tanks. maximum daily consumption will be approximately 1,300 kilogram, and on 27 days the capability of the electrolyzer is not enough. We have also to take hydrogen from the storage area in order to fulfill the necessary consummation of the trains. And 88% of the year the electrolyzer is working. Then we make some estimations. If you have one electrolyzer, you have about 183 days in 25 years, which you have a default. Then we have, if you have 2 stacks, you have 4 days in 25 years, and if you have 3. So we decided to take 2 stacks with each 2 megawatt, and the total investment will be about 4 million euros on this topic, and we have about 1,281 kilograms which we used, and then we decided finally 2 stacks, 2 times 200 megawatt, and I think this is reasonable that we have some days which 8 to 10 days which the system is not working. Total 2 stacks with 2 megawatt each, 88% yearly occupancy rate, and total investment of 400,000 euros. About 4,000 kilogram of hydrogen storage, and the conditions we have in total 5 trains, 4 are in service, 1 is as a reserve. So the maximum consummation per day is 320 kilogram per day. Pressure will be 350 bar, and the maximum time for refueling is 27 minutes, which will be made outside the normal traffic hours. This was a short presentation. The train will start in December 2022. Thank you very much.
Last but not least, we have Hannes Pichler, who is the head of innovation at Innofreight. He will give us a very visual, short presentation on how the Innofreight logistics system works, which is maybe less of a digital revolution, but more of a mechanical revolution. But nevertheless, you please would also be interested to hear what the future holds in your system.
Thank you, Chairman. You cannot see, but time is up. I can see here. Still, I get a few minutes. Yeah, thank you. Thank you that I can be here and I can present our company to you and what we are doing. It's not 100% correct. We are also working on digital topics. We know this is the future also, together with the other things, and it has to be connected in a reasonable way. Several topics were already mentioned before. That I have to say we are also working on this, and I'm happy that there is a common sense about the main topics, like was mentioned, increased capacity and productivity of the railway transport. I think this is one of the key factors of the success of railway system in the future. Interoperability is one of the main topics. Digitalization. Of course, we are working on a digitalization of a wagon at the moment, for example, and also our unloading machines that you will then see a bit later. We are going to make robots out of them, so this is our aim. And there was Mr. Molinari, I think, mentioned that investments should not get lost because money cannot be, let's say, produced endless. Just the central bank can do this, of course. We were thinking about this from the very beginning on, and we know that life cycle problem is one of the main problems in the railway sector because these are very long living assets, and we have to do something with this. So how do I have to press here? 15, okay. Yeah, thank you. I will go over all these slides here now, just focus on the main ones maybe. This was a nice film. It was about timber transport in the north of Sweden. Would be very interesting. But what I want to say about Innofreight is shortly, we are located somewhere in the center of Austria. We are now 90 people. So you can imagine when I started there in 2007, we were 10 people. Now we are 90 people. We have 1,200 wagons running Europe-wide, 12,000 containers already in Europe, and 58 mobile unloading machines and 6 stationary unloading machines. You will see this later then. Our philosophy is that we are bringing together from the very beginning on, and this is what also Mr. Molinari said, we are just more on the logistics side. We are starting with the idea, we are developing the technology, we are developing the logistics solution, things are patented, and then we are doing this together from the very beginning with end customers like steel mills, sawmill, paper mills, etc., and railway companies. And this is also why we have a very low failure rate in our innovation. Most things that we started, we can also bring to the market at the end successfully. This was another film. It was very interesting together with ÖBB, such a iron ore transport, very innovative one. But let's come to the technology and what are we doing and what makes the key success of all these logistic solutions. We see, and this is going into the life cycle topic, we see that we have to separate the rolling stock, let's say. We are basing this on wagons that are very light and that are very multifunctional, and we are putting containers on this. These containers are developed by us, and they are patented, and we are renting this to the customers. So this is one puzzle part. The second is the unloading technology to close the logistic chain. This can be a stationary unloading machine, like here you see one at the coal power plant in Czech Republic at EB Cargo, but there are also mobile solutions with forklifts. And the wagon. Wagon is one of the key technologies, very light, multifunctional, and this is put together at the end and makes the so-called modular system. So the wagon plus the container on this plus the unloading technology brings higher payload. I can just tell you, like in the timber transport, the film that I wanted to show first, we reached plus 25%. In the load, and with this iron ore transport, this was the second film that I wanted to show, we reach from 20 to 40%, depends on the track where we are going, in the plus of the load. Yeah, so you see that we have, especially on the Innowagon family, is very important for us. We have 3 versions, 60 feet, 80 feet, and 90 feet version. They're very light, between 28 and 31 tons. And we have certified it also for white gauge now. So we can also go to the east. And as you see, we have already running 1,200 Innowagons within Europe. Just the different container solutions, it is a bit more than 20 already, can be used for different goods. So we say the wagon should be the same, should run for many decades successfully, but what the customer needs, these needs can change with the time, and we can adjust with the container solution that is put on the wagon. Here you see also for half-ready goods like coils solutions or for wires and pipeline tubes. These are the unloading solutions, the mobile ones that I mentioned before. Stationary unloading machine. Here we see especially potential to make it really highly automatic, so like robot solutions. And at the end, to go over some examples, to the white gauge area, just want to show you we are already active since some years in the white gauge area. We were able to certify now a white gauge Innowagon that could be then at the end used for maybe Russian area. In Finland we are longer already present, and the Iberian market also, where you have in the south the white gauge. We have seen the interoperability from white gauge to normal gauge and the other way around. We need solutions for this. It costs money and time. We are working with our partner Kalmar on a reach stacker, Super Gloria. to shift very high with the weight, very heavy containers, like up to 76 tons, if you have, for example, iron ore transports in an iron ore container, or normal forklift solutions that we are using now also at the border from Belarus to Poland to shift normal containers with wood chips from one system to the other. Yeah, this is also just a few examples. In Finland, we are longer time ready already. It's a good market for us, smaller one, but has in fact almost the same system like in Russia. We are going since many years with iron oxide there, with pyrite also. From Belarus to Poland, we are going with wood chips. This is then the one example with the forklift, where we are shifting the containers at the border. Recently, we could establish, together with ÖBB, also traffic from Belarus to Romania with wood chips. And soon there will be a train going from Belarus to Lithuania, also fully on white coach. So thank you very much. If you want to know more, here is my contact. Thank you again.
Thank you very much. Thank you to all the presenters. I think we have seen a great array of different contributions, and I'm really sorry we can't continue with questions and a debate here, but thank you very much. We have to move into the next session. It was interesting and hope to speak to you soon. Bye.